So you can solve the Saha equation for different temperatures. And then that will give you what is the dominant line that you find in each stellar spectrum. For the G-type stars, indeed, that's the ionized metals that ended up being the dominant. For the A stars, yes, this is the hydrogen lines that are dominant. But for different temperatures, you have different ones. For the M stars, the temperature is only high enough to start exciting the molecules. As you increase the temperature, then you start to have lines of the neutral metals. As you increase the temperature from the K-type to the G-type, you start ionizing the metals, so their relative line strength goes down, and you start to see the lines of ionized metals. That's why G-type have the calcium lines being so, the ionized calcium lines being so prominent. At the F-type, even the ionized metals, you start ionizing the metals so much that their lines go down, and you start to see the rise of the hydrogen lines. You start exciting them. They peak at the A level, at the A spectral type. But then as you go to the B spectral type, you start ionizing hydrogen, and you start to see now the lines of neutral helium. Helium has a higher excitation potential than hydrogen does. And as you go to even the higher temperatures of O-type stars, then you start ionizing the helium, and the lines of ionized helium start to pop up. It's the same idea here. For the M-type, you have molecular lines. As you increase the temperature, the molecules are start to be dissociated. And then at the K-type, you start to see the lines from the from neutral metals. The lines from ionized calcium peak at the K spectral type. At the G-type, you start to ionize them, so it decreases in intensity. And at the F level, you start to have even the lines of ionized metals. You ionize them so much that the metals start to disappear from the spectrum, and you peak at the lines of hydrogen. At the A-type, you peak, and then at the B-type, you start to see the lines of helium as the lines of hydrogen start to weaken because of so much ionization. And at the O-type, the lines of helium, ionized helium, start to become prominent.